So we're going to quickly prove a fact that is used in probability. It's about the Liminf, Limsup, and measure. So the claim one is Lim of mu of EJ is smaller or equal than Lim smaller or equal than mu of Liminf of EJ. Okay. And then here the proof. Well, you need to know that how can we write Liminf in terms of sets? Okay, so this is mu of union intersection, and 1 to infinity k is from larger or equal than n. Okay, so ek. Okay, so let's define this to 1 to infinity fn. Okay, and because fn is increasing sequence, you can pause and think about why. Just write a few examples and you will see why. And then we can use continuity from below. So this is equal to the limit mu of fn where n goes to infinity. So continuity from below. Okay. And also, so since our goal is to show this, right? And we already know that this on the right hand side is equivalent as this. Therefore, we can just show that this is smaller or equal than this. Okay. And then now you can think about what is the relationship between Fn and Ej. Okay. We know that the Fn is equal to intersection k is equal to n to infinity of ek. Let me write out the examples. So it's equal to Fn intersect Fn plus 1 intersect dot dot dot. Okay, and this is so Fn is it contains En. No, Fn smaller than. Sorry, I stated the claim incorrectly, so we'll just show this. Okay. Or we can show this. Sorry about that. Okay, so we know this, right? This is equal to this, so it's equivalent to show this. It's not equal to this. Okay, so we know that Fn smaller than En, so the monotonicity measure of mu of Fn smaller equal to mu of En, right? Okay, and then we can do Liminf. Mu of Fn is smaller equal than Liminf mu of En, and we know that this the limit actually exists, so we just write the limit mu of Fn is smaller equal than the Liminf mu of En. Therefore we're done. And then let's show the other claim, which is so number 2. We want to show that the Limsup is greater or equal than the Limsup of this. Okay, and how do we do that? Again, we're going to make observations, right? So this is equal to the mu of intersection union Ej, which is equal to mu of intersection of Fj, and where Fj is equal to union of Ej, where J is equal to I is equal, sorry, j is equal to I to infinity. And then here's I1 to infinity, j is equal to, okay. So this is equal to I is equal to 1 to infinity. And here, I'm sorry, I should define fi here. Okay. And so it's equivalent to show this, right? This is, okay, sorry, one more step. This is equal to the limit of mu of fi as I goes to infinity. Notice here we use the continuity from above. And notice that there's a constraint, and let's see if we satisfy the constraint. So it has to be mu of f1 is finite. Well, this is equal to mu of union j is equal to 1 to infinity of ej. So this is finite and this is given. Okay, so we have the condition satisfied. We can therefore use a continuity from below, from above. I'm sorry. So this equivalent show this is large or equal than show this is large or equal than this. Okay, and how we do that? So let's observe fi is equal to union j is equal to 1 to ej, and then we know that this is equal to ei union ei plus 1 union da da da. Okay, and then what do we have is we have the measure fi smaller or is larger than the measure of ei. Okay, and then we can do Limsup on both sides. Limsup on both sides. The inequality doesn't change. And notice that the limit actually exists. So we have the limit mu of fi is larger or equal than the Limsup mu of ei. And therefore we're done, because once we prove this, okay, the equivalence proves this because the equality we proved earlier. So I would remember, so like if we're dealing with Liminf, so whatever outside is larger. And if we're dealing with Limsup, then what is outside is smaller. Okay, that's it.